Hello guys, this episode is brought to you by Fieldpiece. The tough wireless vacuum gauge MG44 from Fieldpiece is engineered to give you the reliable reading you need and the ease that you want. Confidently measure vacuums with a reliable leak-proof seal. The MG44 can be used with the JobLink system app from up to 1,000 feet away. This easy-to-read backlit LCD offers a graphical representation of the vacuum progress, even in low light or at odd angles. Visit www.fieldpiece.com for information or follow us on social media at Fieldpiece Products. Thanks again and enjoy the episode.
We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of day or night to check stock on your favorite brands, such as Copeland, Sporlan, Carlisle compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann parts, and K2Therm. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live-to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
John, how can you always have the right TV for the right application without carrying hundreds of valves on your truck?
You can carry the hundreds of valves on a trailer behind your truck.
That's too funny. That would work, but how are you going to do that? Maybe there's an easier way.
You can use Sporlan's interchangeable cartridge style Type Q and Type BQ TEVs. Type Q is a conventional design and Type BQ is a balanced port TEV.
Well, come on, I need easy. How easy is it?
Easy as 1, 2, 3.
And it serves thousands of unique applications. So what's the process? How do I put this together?
First, you select the thermostatic element assembly. Then you select the body that you need. Then you select the right size cartridge for the application to get the proper capacity TEV for your application. And then I guess it should also be said you want to actually assemble those into a single valve.
That'd probably be a good idea.
Indeed.
These easy to select and assemble valves mean you're always carrying the right valve for the right job then. If folks want to learn more, what do they do?
You can go to sporlan.com and find more information on the Type Q and BQ thermostatic expansion valves.
I guess that's Jim and John for Sporlan signing off.
Yeah, so this is going to be a fantastic show.
Yeah, it better be, because tonight we're keeping score.
Yes, and on a scale of 1 to 10, here's your score so far.
Good morning, guys. Welcome to the Advanced Refrigeration Podcast. I'm your host, Kevin Compass, and today we're going to be going over another tech tip. We're going to be going over door heater troubleshooting. Seems pretty simple, but there's a lot of guys that struggle out there with this. So we're going to be going over specifically Anthony frames and Hussmann frames. So without further ado, let's get this started. So guys, today we're going to be talking more about like icing and frosting issues and sweating issues on door frames. When attacking this problem, so there could be multiple issues that cause sweating and icing on door frames, not just heaters out. So I want to go through each of these and show you guys how I attack these. So first and foremost, when you have sweating door frames and sweating doors, the first thing I'm going to check is when I'm walking in the building is the dew point in the store. You want to keep that dew point in the store below 50 degrees. You want that relative humidity in the store below 50%. When you get above a dew point of 50 degrees, 55, 60, you start getting into the point where you're going to start sweating and condensating in the doors. So if you look at like a enthalpy chart and you look at it, it'll tell you at what temperature it's going to start condensating. So say you have a 55 degree dew point in the air and your door frames are 50 degrees, you're going to sweat. If your door frame temperature is less than the dew point, you're going to condensate. So this is where it is imperatively important to get that dew point down in the store and keep that store dehumidified so that you don't have this condensating issue. So anytime your dew point is higher than the surface temperature of whatever it is, doesn't matter if it's a medium temp case, a glass door, a walk-in panel, anytime that panel or piece of material is less than the dew point, it's going to condensate. Just like outside with the grass. You wake up in the morning, that grass is colder than the actual air temperature. In the humidity, the dew point is higher than the actual temperature of the grass, or the windows in your house. So that's how the condensation forms. Condensation could be a twofold problem. It could be a material issue, or it could be a environmental issue. Environmental meaning your dew point is too high, or a material issue meaning like you have failed insulation in a case, you have failed insulation in a walk-in box, you have air infiltration causing the material temp to drop. I want to go over a couple things, guys, with that. With it being said, the humidity problem, we've gone over a couple episodes further back to tackle the humidity problem, but making sure the dehumids are working is like key. Other than that, I want to tackle the actual material problem today. So say we're going to start off with door frames. So say if you have door frames sweating and the humidity in the building's not super high, it's dew point's 50 degrees. I'm going to take a laser or a contact thermometer. I have a thermal imager, but I'm not going to go over that because that's not available to most guys. But a laser or a contact thermometer, and what I do is I take that and I check the actual temp of the material, the frame, whatever it is. I'll check the actual temp of it to see what it is. If it's lower than the dew point, then we know we have a problem. So what I want to do is figure out why that material is lower than the dew point. And if it's glass doors, okay, so we're starting off with frames. Everything now pretty much coming out new has anti-sweat controllers in them. So meaning what they're doing is they're checking the dew point of the store and the actual temp of the frame, and they're cycling the heaters in the frame. Now, this works very well if set up properly. It gets a lot of bad rep, but like you guys got to understand, if you have one 5-door section pulling 5 amps and you have, say 55-door cases, that's a lot of amp draw. And for the majority of the year, you could save a lot of money by turning those on and off. It has to be applied correctly. So I've seen Hussman, I've seen Hill Phoenix do this. Anthony has their own controller. Hussman has their own controller. There's all kinds of retrofit controllers. But if they are not set up properly, there's a dial on there that could change the dew point setting for when this goes full on. So these need to be full on at 55 degree dew points. So at 50 to 55 degree dew points, these controllers need to be full on. Whether the EMS is controlling it or whether the case controller is controlling it. The cases, I know a lot of them came out adjusted wrong. So there's a sticker over the end of it. If you cut the sticker off with a knife, just peel it up, and you look on there, there's a dial potentiometer on there. If you turn it all the way to the right, that's going to make it go full heaters at 50 degree dew point. So that way you won't have this condensating issue or icing issue. Same with Anthony ones. They're in the middle door mullion. And same with the Anthony frames. They're all in the middle door mullion. You'll find the anti-sweat controller. So all new Anthony frames come with the mullion controller already installed in there. The big thing I've seen here lately is they'll have like an EMS controlled mullion heater that's pulsing using a solid state relay. It's pulsing the power to the doors, and you can't do that if you have the installed relays of the cases. So you either A, have to jump the case ones out, or B, you have to not utilize the EMS controlled one. You can't have both, because when you start pulsing it, it never lets the controller at the case power up and start regulating the heaters. So the one at the case needs constant power. So if you try to pulse it off the EMS, it's going to be a problem. We did a bunch of glass doors last year, and this was a problem. They had some old anti-sweat controllers installed that nobody really knew about, and they were hidden in a motor room somewhere, and they were still active, and they were pulsing, and they were pulsing against the Husband controllers, and we had constant door frame issues. Not so much icing up, but like they were never maintaining proper temps on the doors, so that they would condensate all over the frames. So that's one thing to be, keep in mind, guys. If you're doing startup on these cases, make sure that if you have the anti-sweat controllers in the case and you're using EMS ones, just jump all the ones out of the case. All you got to do is cut 2 wires and tie them together. And if they're the Husband ones, they're super easy. If they're the Anthony ones, I mean, me personally, if at that point, I'm probably going to jump out the EMS relays, because I don't want to take apart that many door frames. It's a pain in the ass getting the contact plates off the Anthony doors. So it really just depends what the customer wants. If you talk to the customer and say, hey, listen, these came on the case, they're a DOE requirement. Do you want to use the EMS, which I would always rather use the EMS just because I have control over it, or would you rather use the controls of the cases? And likewise, that should be a change order to fix all those. You need to make sure that they're functioning properly. The way that these work is they have a dew point sensor in them, and then a temp sensor that's on the frame. It's measuring the frame temperature. So that dew point sensor is usually looks like a little black, kind of like a mushroom. And it's usually on the far left-hand door, and it's at the top of the door, touching the frame. So it's measuring the frame temp and the dew point, and it's doing a calculation to see if it needs to turn the heaters on or off. Those sensors do go bad. So if you have one not operating properly, it's probably a bad sensor. And I mean, in the meantime, you could bypass it for now. If I find one that's failed, I usually order a module and a sensor, because you have no way to troubleshoot the sensor, because it's in a phone cord usually. So in order to troubleshoot it, I mean, it's pretty difficult. And the amount of time to try to troubleshoot it, you're better off just ordering the anti-sweat controller and the sensor. That way you could just change both if need be. The parts are so cheap compared to labor. At this point, it really doesn't matter. So I usually order both. So the way that frame sensor works is it's monitoring the temperature of the frame, and as long as the frame temperature is warmer than the dew point, it's going to cycle the heaters. And if the frame temperature gets lower than the dew point, it's going to shut the heaters off. So that is how Anthony is controlling those. Certain manufacturers cycle the door heaters. Anthony does. So they actually cycle the actual door heaters themselves. So you have the heaters inside the doors to keep the doors from fogging up. So Anthony is actually cycling those also. So if you have a door that's fogging up or a door that's condensating, so there's a couple ways to troubleshoot this. If there's moisture in between the frames or the glass panes, the door's junk. Right? Don't even waste your time. The door's junk. Like the seals failed in there, and there's nothing you can do about it. Replace the door. So if you have a door that's condensating on the outside, the outside of the edges of the door, or the glass is condensating. So first things first, if it's just one door, okay, it's probably a door issue related to that door, or a plug issue. If it's every door in the case, it's probably a anti-sweat or a power issue. If it's all the doors, then it's probably either a power issue or it's a dehumid issue. So that's how I generally start to attack these. If I see an entire store sweating glass doors, okay, I'm going to think dehumid first. I'm going to check my humidity and my dew point, and then I'm going to move forward from there. Or then I'm going to look at the EMS to see if they're controlling the anti-sweats, and if they're not, then I'm going to move on and start checking how they're set up. So first things first, if you take a good amp clamp and leave the jaws closed and stick it on the door, it'll read amp draw. So it'll tell you right then and there if that door is working. I see guys use the hot stick all the time. Like they'll take one of those non-contact voltage meters and put it on the door, and it'll tell you if the frame's energized. If it has power going around it. The only thing that I don't like about that, if the heater is broken, you'll still pick up non-contact voltage because you still have a hot leg on one of them. So what I like to do is use the amp clamp. If you put the amp clamp to the glass or the frame, it'll actually pick up the heater. Now you have to have a decent amp clamp to do this, but it'll pick up the heater amp draw very, very slightly. It might be like 0.1 or 0.2 of an amp, but it'll still show up. Now what I like to do is I use a thermal imager. I mean, Flare makes a TGI like 165 or something. It's a real affordable imager. What I like to do is I could scan the entire aisle and see, if I'm doing a PM, okay, I could look. I'll see red door, meaning it's it's heating, and I'll see a blue door. Blue door is not heating. So once I find the door that's not heating, on the Anthony doors themselves, if you open the door on the end where the handle is, on the edge of the door, there's a little plate you can pull off about halfway up the door, and there's wires in there. You pull them down, you'll see wires that go to a heater, and you'll see wires that are coming from the top. They're coming from the top plug where the door gets its power. So before I condemn a door, I pull the power off, I disconnect the wires, and I shove my meter in there to make sure I'm getting 120 volts. And then I will check the actual heater ohms on the door frame itself. So on the door frame, on the door itself. So you'll see it'll have like a heater wire on there where you could, let's say, a quick connect, like butt splice almost, a male and a female. So you ohm out both. If it doesn't ohm out, then I'm going to write up a door. The labor it takes to change a heater in a door, I've never done it, but it's pretty extensive. To me, it's just better off getting a new door. If a door frame for heaters failed, I'm just writing up a door. So I'm not going to take the time to change a heater in a door. I mean, that's a lot of labor by the time it gets done. And if you crack the glass, you just lost a bunch of money. Same thing with the husband doors. They also have a heater in them. I don't know if you could change those. I've never even seen the part for it, but at the bottom of the door where it's a lot easier to check the husband doors because if you pull the kick rail off, everything, the power feeds down a strip down into the kick rail. So you have a male and female spade connector. You can unplug it, make sure you got power there, and then you could ohm it out to see if you have a bad heater. The husband doors do have a screw-in harness on the side that does fail from time to time. You may have to disconnect the harness. It's just 2 screws on the bottom side of the door. Pull the harness out, and then you could ohm out at the door to see if it's bad, to make sure the harness isn't bad. I've seen quite a few harnesses burn up and fail, so just keep that in mind also. Door troubleshooting, simple heater in there, just make sure it's good. If you have condensation between the glass is done. You want to make sure the glass is above temperature and the heater isn't cycling if the dew point is high. So say like you get there and like you check the heater, it's working, but then you watch it with the amp clamp on there for a little bit, and then all of a sudden it drops power, and the power comes back. It drops power comes back. Well, now you know that you're cycling on the anti-sweat controller, but you're cycling early like you shouldn't be. You need to figure out what's going on with that. Whether you got a bad temp sensor, there's a pinch in the heater by the frame, by the temp sensor where it's just getting hotter. So just keep that in mind when you're looking for stuff like that. Now, there is a bunch of husband doors, the innovator doors. I forget the date code on it, but it was like maybe like 10 years ago when they first came out. You couldn't cycle the doors on them, the door heaters on them, because the doors were exploding. So when you cycled the heaters a bunch of times, the doors were exploding. So husband changed out most of those because most of them did explode. But just be aware when you're retrofitting, like say you're installing anti-sweat controllers for like energy retrofits. If you come across some like 8 to 10 year old husband cases and they don't have them on there, you need to call a husband and check to see if those innovator serial numbers come in that date code, so you don't blow up all these glass doors at $1,000 a pop, and then your customer is just furious. And the husband obviously is going to cover 10-year-old doors. So the next thing I want to go over is writing up a door. So writing up a door, you guys need to get some information. if it's Anthony, the tag is on the top of the door. You need the work order information. That's what they need. All the information is on that top tag. So I usually take a picture because all the information is ridiculous on there and it's like super long. So I'll take a picture of the work order tag. It's on the top of every single door and it's on the door frame. If you're writing up a door, you need the door information. So you need to take a picture of that. If it's a husband door, if you peel the gasket back, if you open the door, the left hand, if you're looking on the inside of the door, the left where the gasket is, the left hand side of the door, upper top, peel the gasket back. Top left hand corner, peel the gasket back. On the left hand side, about a quarter of the way down, is going to be a husband tag with all the door information. So you need a picture of that, and in that way you could order a door for that case, not off the model and serial, because that case could have come with Anthony doors or it could have come with Innovator frames. So that's one thing to keep in mind when you guys are ordering doors. It's one thing I see guys miss a lot and causes a lot of havoc when trying to get parts. Anthony's real difficult to get parts from right now. So like if you don't have all the work order stuff, they're not even going to help you. So keep that in mind when you guys are writing up doors. I mean, doors are pretty simple, but if you see a door and you're going to replace it, I mean, if it's an Anthony door, I always order a Torque Master because it's probably junk already or it's wore out. So just do yourself a favor and order a new Torque Master with the door so that way you aren't fighting it, or you go to put it in, the Torque Master falls apart. And then same thing with husband, order a new torque rod and order a new contact plate for the torque rod because the contact plates strip out all the time and you don't want to go take a door off and the contact plate for the torque rod's messed up. So let's go over tensioning a door. So a husband case, there is on the bottom of the case, there is a tension rod with a nut that basically rides on a contact plate. So what you do is the top of the door's got a pin, a spring-loaded pin that holds it in. The bottom of the door has this knuckle where this half-inch nut fits in. And what you do is you have to tension the door in order to do it. So what I do is I took a half-inch wrench and I ground it down halfway. And it fits perfectly on the bottom of the door. So that way you put a little bit of tension with a screwdriver to pick the door up a little bit. Now I can turn the wrench and I can drop the door back down. Then I'll reposition the wrench and I'll put tension on it and then I'll pick it up with the screwdriver and I'll tension it some more. You know, you just want it enough where the door is going to close on its own. You don't want it to where it's going to slam and catch some old lady in there, but you want it to where it's going to tension enough on its own and you won't have any problems. Now, Anthony uses what they call a Torque Master. Torque Master for Anthony adjusts the torque of the door. You have a screw on the side that adjusts the torque of the door, and you have a screw on the front and on the side that adjusts the sag of the door. So sag meaning like how level the door is. So if you ever look at a door and you see sawtooth, meaning like the back of the door is higher, the front of the door is lower. Then you look at the next door, back of the door is higher, front of the door is lower. It looks like a saw, like up and down, like the teeth of a saw. So you don't want that. You want them all to be level. So what you have to do is you have to adjust the sag of the door and the level of the door. And that's through the Torque Master. So you want to tension that. And if it's, you're screwing it in and out and it's not doing anything, it's not tensioning or loosening the door, the Torque Master's bad. And they're kind of a pain to change. You have to take the entire door off and then unscrew it. But that's how the Torque Master works briefly. So let's get into frame troubleshooting, guys. I see so many guys struggle with this. And I don't know, it's the struggle because they don't want to take the time to investigate it because, frame issues can become kind of a problem, a nightmare, because they're kind of labor intensive. So we'll start with a husband frame. Husband frames have one heater for the entire frame. So it's one continuous heater through the entire frame. Super simple design. Honestly think it's the best. So you have one heater going through the entire frame. It comes in one side of the case, goes out the other side of the case. So usually the left and right hand side door, there's wires coming down. They come into a terminal block where they get their 120 volt power. So whether it's fed off an anti-sweat controller, so that's what you need to check. So usually if I got no frame heat, the frames are cold, I got ice on them, I will go down, I will find the wire connections, I'll pull them apart, I'll see if I have power for it. I've seen so many guys mess this up and they have no power, or they check the ground and they have power but no neutral. In the terminal blocks for the Husband cases, the neutral comes loose a lot. So you want to make sure you have a neutral. And then in the Husband cases, when they go into defrost, they kill the frame heaters so they don't overheat the case. So if you look, there's a relay down there, like the ones for the fans that fail all the time. That same relay is right next to it, is also controlling the frame heaters. So if you do have an issue, you may have a bad frame heater relay. That is the number one failure I see in these Husband cases. Guys will condemn a heater in a case, and the heater's fine, but the relay's bad. That relay is brought on by the defrost heaters, or it's brought on by the fan control setup for hot gas, and that's how they're doing they're cycling the anti-sweats. And then you could also have an anti-sweat controller in there. So verify you have power first. As long as you have power, now you're going to ohm out the heater. If you ohm out the heater and it's open, you have a problem. If it has ohms, it's good. You need to move on to something else. So if it's open, then you're going to go ahead and stop there, and you're going to order a heater for the case. Usually it's a 1 to 2 man job. If it's a 5-door case, I'm going to have 2 men do it, usually an apprentice. So changing the heaters on the Husband cases, you got to peel the contact plates out, kind of a pain, use a control screwdriver. And then what I do with them is I go to like Home Depot or Menards and get a screen roller, like a replacement to replace screens and like a screen door. So it has a groove in it, and basically what you're going to do is you're going to roll that heater into the frame. So otherwise you got to push it in with your fingers, and it's kind of a nightmare. I mean, hands are going to be all messed up from doing it. So like the screen roller though, it'll take it and it'll roll the heater in there perfectly, and then it'll save your hands. After you get the heater in, what you're going to do is you got to put all the contact plates back on. You got to be very careful because these are all fiberglass. So do not hit them with a hammer. Just very gently peel them out with the screwdriver and very gently put them back. So you want to get all the contact plates back in there, and then you install the heater back and then test the amp draw. Usually it's like 5 amps for a 5-door, 4 amps it's usually like an amp a door, it seems like, for the actual Husband heaters. So that's how you check those. Now, Anthony, this is where it becomes difficult. Anthony frames have anywhere from 3 to 7 heaters in them. So a 5-door heater can have 5-door case can have 6 or 7 heaters in them. So that being said, if you have Anthony frame heaters not pulling amp draw, there is no way there is 6 bad heaters. I see guys write this up all the time. They order all the heaters. There is no way possible you have 6 bad heaters in one door frame. I'm not buying it. Okay, so you could have 1 or 2 bad heaters, and it's dragging down the door frame temperature because all those contact plates are coming in contact with each other, so they'll actually drag down the frame of the door. So you need to figure out what door frame's not working. Now, the way I do this is I have a thermal imager, cuts time down in half. I can see exactly right now what frame heaters aren't working. Okay, if you don't have that, get the laser thermometer out and start checking areas of the frame and see which sides are colder. Obviously, if it's just the right-hand door doing it or the left-hand door, you know that, okay, it's probably just that frame heater. So what you do is you pull the contact plates off, find the frame heater in there. So you pull the contact plates off. There is clips on the side. You'll see black clips. They're like make a 90. You're going to peel those off with a control screwdriver. Be very gentle. And then you're going to peel the contact plates off. Do not bend the contact plates because you are going to have a nightmare getting them back on. Pull them off gently. Lay them straight on the ground. Don't let them bend. So I struggle with this all the time. I hate putting contact plates back on. I'm very bad at it. So take your time, and then find the heater connections. They use Wagos to connect the neutrals and the hots together. I see a lot of times the Wagos fail. So you'll be getting power into the door frame, and you'll be getting power into the heater controller, but you may have 1 or 2 heaters not making good connection in the Wago. So I've had a lot of times where I end up cutting those out and using crimp nuts in order to connect all the heaters together because the Wagos over time seem like they get a bad connection. So just keep that in mind. Make sure you actually have power at that heater. So, and then trace it back and find that broken wire. Second of all, if none of them are working, verify that you actually have a hot and neutral. I've seen it where neutral wires break.
Today's episode is sponsored by the new Reseal differential pressure monitor from Westermeyer Industries. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The new Reseal RDP-01 differential pressure monitor is available now from Westermeyer Industries. To find out more information, email sales@westermeyerind.com. That's sales@westermeyerind.com.
I've seen it where neutral wires have issues, so you want to make sure you actually have a hot and a neutral in there. And then check the connections. I mean, to find out which heaters are bad, you may have to pull off like 5 or 6 million panels to see which heaters are bad. But then you could look at the Anthony website and order the heaters you need. Don't order all 5 heaters because you're not going to install all 5 heaters that are bad, or if you do, you're going to waste a bunch of time because putting all those heaters in is a nightmare. Unraveling them, trying to figure out which heater you need for which door, it's a pain. So just troubleshoot the heater that's bad. If it's an Anthony frame and it's pulling no amp draw, there is no way possible every heater's bad. So you have some other problem, a power problem, a wire connection. So just keep that in mind when you're looking at these Anthony frames. Now, with that being said, I have had a ton of brand new Anthony frames. So they reduce the heaters in them on the brand new frames because they're trying to lower amp draw consumption, show that they're better, show they're saving energy. So they excluded the heater on the top rail of the frame heater. So there's no more heater on the upper top. So what is happening in all these cases, the actual top trim piece of the case is getting below dew point and sweating. I've seen this at multiple Aldi's, Costco. I've seen it at Walmart now, where the frames are sweating. The actual outsides of the frames and the above where the contact plate meets is sweating. So every door frame I've looked at so far, it usually starts about 3 months at your startup. Every one of them I pulled the top rail down, the top contact plates down. They're all full of ice. And what's happening is where the power connection comes in. It's from Anthony. It's metal flexible conduit, so it's BX wire. It should not be. It should be seal tight. Because here's the problem: there's no way to properly seal that, and that's a factory Anthony connection. So there's no way to properly seal that. And Anthony is just putting silicone in there, and they're not putting enough in. So what's happening is from where the wires are, the condensation's building up on the backside of the contact plate, and that ice is causing everything to frost. Everything is causing it to frost on the backside of the contact plate, and then ice starts building. Once that ice starts building in there, that lower heater, that low amp draw heater, cannot maintain the frame temperature at the top anymore, and it's getting below dew point. I was seeing like multiple doors at 50 degrees, 45 degrees, 55 degrees, but it was on humid days, it was causing all the doors to sweat. And you go there, guys would go there, all the frame heaters are working, everything's working fine. Like they would say it's a humidity problem. Well, then the humidity's fine. And you look in there and you pull the top frames down and there's ice in every one of them. So what I had to do was take a heat gun and I had to melt out all the ice at the top, and I had to heat up where the wires were. I heated it up as much as I could safely with the heat gun, and I shoved a silicone, like quad silicone, the really good stuff from Home Depot, and I filled that entire cavity where the wires were, just packed it full of silicone. And then all around where the wires came out inside the frame, packed it full of silicone. So that way that I could keep that ice from building up in there anymore. Some of the frames are on the bottoms, but I must have did 35 frames. So on every Aldi build now, I make the carpenters or the electricians, before they finish landing all the wires, pull the BX apart, the 90 on the BX, and we literally fill it full of silicone. And we silicone all around it. like a glob of it, so that way it properly seals the connection for the wires, and then we don't have any more problems with the frames condensating. The last 3 stores we did that at, we didn't have a single problem with the frame condensating, but every single one that I've pulled apart has had ice in it, and it's from bad connections. And I've also found that like when these guys are installing like the big walk-in boxes at Costco, there's a gap in the top of the frame on the back side. On the back top of the frame, there's a gap. They were supposed to fill that with full of butyl, and there's another plate that needs to go up there. And they didn't do it at a lot of these stores. They didn't fill them full of butyl. So what happened is the ice got on in between that crack right there. Now the face of the door is sealed with butyl to the box, but that crack in there, it was allowing the top edge of the door to get ice on the edge of it from the backside. You couldn't really see it unless you got up in there and looked, and you'd have to almost pull some product out to get to it, but you couldn't really see the backside of the frame. And what was happening is that ice was causing the door frame temp to drop because it has these low amp draw heaters in there. It was causing the door frame temp to drop only on the top, so the tops of the doors were sweating. I mean, Hill Phoenix was out there trying to troubleshoot this, and I found a bunch of them that we ended up just taking silicone and we warmed the box up a little bit. They moved some product, we warmed the box up, and we just butyled it because silicone isn't really a stick in that situation. So we butyled it and just got the ice out, butyled it tight, and then after a little bit, whatever remaining ice was in there melted out of the door frame because the door frame temp was able to come up because it's not having that cold air hit it. So anywhere that there's air leaking around the door frame is going to cause the door frame temp to drop and everything to condensate. So you need to really just pay attention to that. So any air movement in there. And then the other thing is we've been having a lot of problems with the new Anthony doors is if there's air blowing directly on the door. So for Aldi, for example. So Aldi switched from a lot of Hussman stuff to a lot of Hill Phoenix stuff. So the Hussman stores, we only had 2 giant coils in there. And they were in the center of the box. And they had we put air hoods on them to curve the flow down. Well, now we have 3 to 4 to 5 fan small coils. Well, they're high velocity throw coils. So small walk-in coils. The problem with that is the air is hitting the doors and the tops of the door frames, so it's dropping the temp even more. So, but as before, like that big coil didn't have as much throw. These smaller coils have a larger throw on them, and what it's doing is it's causing air to hit the doors, and these new energy efficient doors honestly cannot keep up with the temperature. So they don't want air directly blowing on the doors because it'll cause the door frame to sweat. So that's one thing to keep in mind. If you have air directly blowing on doors, that heater may not have enough goose in it to actually heat that door up. So you just want to keep that in mind. And the other thing is on that, if you're cycling the door frame heaters and you do have that blowing on there, you may drop the temp, even though the frame is good, you may drop the temp on the door too low and it may condensate. At Aldi, it's less of a problem now because they have such a small store and the CES does such a good job of dehumidifying the store that the dew point's usually relatively low in Aldi's most of the year. So with that being said, I mean, it's less of a problem now, but the majority of the problem I found with those door frames sweating was ice in the frames at the tops. And it was usually growing from the right-hand side where the power connection was all the way across. So wherever the power connections were for the lights and the frame heaters is where it was growing out of. And after I fixed that, a lot of the problems went away. But we've had a couple stores where we've had to deflect the air down on a couple fans. So we've had some like custom hoods made, like a kind of like a 35, 40 degree angle where it just kicks the air down the floor, so it causes it to swirl and hit the floor. So to make it so it's not just like directly blowing on the door. So after you troubleshoot that, and you have no ice behind the frames, you have none of that, and you get these frames going, and say you have a bad wire connection and you get the frame back heating, you're going to check the amp draw on the frame heaters. You're going to make sure they're working. Go to each, if it's Anthony, I go to each section and I just stick my amp clamp by it to see if it's pulling amps on the frame. Just like you can with the doors, you can put your amp clamp by the frame to see if it's pulling. Once your frame starts getting above, freezing, at that point, you're going to start melting all that ice off. Just be careful. Make sure no customer slips and falls. Have them bring the mop bucket over there and start mopping it up. It's going to be a giant mess if it's giant ice balls. So the other thing that could cause frame sweating, icing and stuff is bad door gaskets. So check the door gaskets. Door gaskets are an easy thing to write up for apprentices to do. If you have a lineup with like 5-6 bad door gaskets, it could easily cause enough air infiltration in there to cause sweating and ice buildup in the cases. So what you're going to want to do is check the door gaskets. I haven't changed a lot of door gaskets, but it's a pain in the ass every time I go to do it. So a couple things I've learned to help with that is take deodorant and rub it on the gasket dart piece so you could actually push it in there, or tire shine. To be honest, tire shine works the best. Older guy showed me this, and what he would do is he would get a bunch of tire shine and he would dump it in like a can, and he would get a brush and he would brush the tire shine onto the dart face of the gasket, and then it literally slips them like butter. So just make sure when you pull the gasket off, I run the channel down with a control screwdriver to knock any ice that's in the channel out, and then I will put the gaskets back in with that. So if you are ordering gaskets, make sure you're getting the OEM ones, or I've seen twice now we've been at Walmart's where they've ordered from some gasket place, and it shows up and they're like 2 inches too long or 2 inches too short, or then you have a giant pile of rubber that you can't even use, and they're not usable for any cases. So I usually order the OEM gaskets, and let the apprentices do them. I've only done a handful of gaskets. That's not by choice. It's just nobody wants me doing gaskets. It's just not financially feasible. But door gaskets are a number one most overlooked thing with door sweating and everything else, because if that cold air is coming around that door and you have that cold air blowing across the frame because it's not making good contact with the gasket, that's going to cause the frame temperature in that area to drop below dew point. And once where that gasket leak is, where that frame temperature is, it's going to, hot goes to cold, it's going to make condensation. So where that gasket leak is, it's going to cause an issue. What I generally do is when I'm checking doors, doing a PM, I'll check out every door. It seems like gaskets always fail, usually on the door handle side. I don't know if somebody can explain this to me, if it's a customer thing or what. I don't know if these customers open the door and grab the gasket or what, but they always rip right there. So it's got to be a customer deal with them ripping the door gaskets. I'm not really sure. It's insane to me. And then another thing to keep in mind, on the Anthony stuff, is the contact plates. So you have these metal contact plates that cover the door frame heater and all the wires in there. I see a lot of times where the plastic pieces break off that hold the contact plates on, and the contact plates get bent or missing. So I see this all the time by us. The stockers stand on the contact plates. So they stand on the door frame till they get to the top of the case, and they end up breaking the plastic pieces off, and the contact plates get messed up. If the contact plate's gone, the door frame heater is not going to work worth the shit, because there's nothing for the gasket to seal against. It's just sealing against the edge of the frame heater. So that's a problem. And then also you have all this exposed wiring, and it's going to build ice, and you're going to have frost inside the case because all that warm air is going to go right inside the case. So making sure those contact plates are all installed. When I'm doing a PM, I'll do a walk, and I'll just make sure all the contact plates are there and make sure everything's there. So that way I can make sure that, everything's functioning properly. And then make sure that everything is, getting warm on those Anthony doors. Those Anthony doors are, taking those contact plates apart is a pain. You just got to get them in straight and, finagle them with a control screwdriver. And then literally I'll take the contact plate covers, they're the clips, and I'll just, work them back and forth with the palms of my hands to get them to clip. Once you get it started on one side, you can literally run your hand down and get them on there. I'd maybe take a plastic or a light mallet, and you could pop them in a little bit, making sure that they get all the contact plates are on there if you have door sweating. So that's a big one. And then making sure everything is sealed. And then on the Anthony doors themselves, they have a socket that goes, or in a plug that goes in the top of the door. So that plug on the top is your actual pivot point for the door. That's where your power comes down too. Those fail all the time. I carry the plug, both sides of them on my van. The upper plugs, I'm pretty sure you have to drop the frame out to change them. I've never had to do one, but the actual plug that goes in the door, I have a ton of those. The sockets, they fail all the time. So I usually carry, for parts in my van, I usually carry Torque Masters. I'll carry Hussmann torque rods because they're all the same for every door. I'll carry some torque rods we use for Aldi for my truck stock for the Anthony doors, and then I'll carry Torque Masters and plugs and hinge pins. They call them hinge pins at the top. So you have powered hinge pins and non-powered hinge pins. Non-powered hinge pins would be for medium temp doors. Powered hinge pins would be for low temp doors. You could use a powered hinge pin in place of a non-powered hinge pin in a pinch. It's just you won't use the wires. It's more expensive. You could use the other one vice versa to keep the door from falling off, but then the door frame heater is not going to work. So having those hinge pins in there is viably important, because if that hinge pin breaks or the clip breaks, it's going to fall on a customer. So same thing with a Torque Master. I mean, those are easy parts to install. Like if you're slow, go through them hey, this got a bad Torque Master. This, check on the doors, make sure they close and it has no door tension. Okay, well that's going to cause condensation or ice buildup in the case if you have no door tension on there. So you want to make sure that you check all the hinge pins and everything else. You don't want any loose hinge pins. So to do the hinge pins, what you have to do is you have to pull the door off. You pull the door off, put it on the ground. You're going to open up the side access where the heater connections are. You're going to disconnect the heaters, and you're going to pull that hinge pin out a little bit. Now what I do is I do it like this. I pull the hinge pin up a little bit. I cut the wires. Now what I do with the new hinge pin, I will tape the wires to the old wires, and I'll use them to pull it down. Don't just pull the wires out, because you're going to fight getting those wires back in. So use the old hinge pin wires to tape to the new wires. So when you put the new hinge pin in, you can pull the wires down through the sides. So that way you aren't fighting it. Okay, you put the wires back in, you connect them. You're going to reinstall the door. You're going to tension the torque rod. You're going to make sure it doesn't have any sawtooth. And then you're going to check the amp draw on the door to make sure it's working properly. Make sure you're getting voltage out of the hinge pin. Before you condemn anything, see if you got voltage. And if you aren't getting any voltage out of the hinge pin, pull the door off and check it at the socket. Make sure you're getting voltage there. If you're not getting voltage there, you have an issue in the door frame, or you have an issue in the actual socket itself. So just keep that in mind, guys, when you're troubleshooting these. If it's Gemtron doors, I'm pretty sure you can't get parts for those anymore. As far as I know, Walmart's going around. They're changing all the Gemtron cases to Anthony door frames. So Hill Phoenix has a retrofit kit for them. I know they were selling some doors for a while, but I mean, the last couple I put in were a nightmare. I refuse to try to change the tension rods on the Gemtron doors, because the last two I've done, I've broken the doors. And because they're so rotted in there, I refuse to touch them. The Gemtron doors, halfway through the middle, have an adjustment Allen key in there, and that's how you tension the door. Just be very careful that you don't over tension it. So it's in the middle of the door, halfway up on the opposite side of the door handle is the actual tension. It's just an big Allen key you stick in there. So that's the Gemtron doors. I mean, we only had a couple Walmarts with Gemtron doors, and I'm pretty sure they've all been retrofitted to Anthony door frames. So they went through and put brand new frames in. We've seen a lot of issues with those installs. They aren't sealing them properly. So making sure that you go back, and if you are having problems, make sure they seal the electrical connection on the bottom, and make sure they actually sealed good around the frames. I've seen a lot of spots where they didn't butyl them properly, so that's another issue. But generally, we have to shut the case off, and a carpenter comes in and he reseals and butyls it, after those guys left. That's the issues with those frames. The last thing I want to go over is just making sure the actual frame itself is sealed good. I've seen a lot of Anthony doors at Targets where they're 20 years old, in some Tyler cases, and the actual frame is not sealed good anymore. So if you are having condensation and you're getting cold air coming in to the actual frame when you got it off, and like the actual frame is super cold, you may need to go back and reseal the backside of the frame to the case. So what has to happen is the case has to get shut down. You have to rebutyl the inside of the case, like around the frame edge. If that is happening, if ice is getting in there, you have to let the ice melt out first. So shut the case down, tell them they have to pull the case and empty it, and then you have to rebutyl the inside of the frame to keep that air from infiltrating, or ice from infiltrating the frame edges. So that'll cause the frames to condensate because you're dropping below dew point. And then lastly is LED light installs. This has been a huge problem. It was like a huge problem a couple of years ago. It's kind of died off because most of them are done. But these LED light installers, what they do is a lot of times they'll drill new holes for the light to go into. They'll pull the contact plates apart. They'll drill new holes in the case, and they weren't sealing the holes they were drilling where they ran the LED wires through. So I've seen a ton of them where they were getting ice buildup in the back of the frames or air coming in because they weren't sealing the frames properly. And they put all these holes in the cases, so you figure you have 5 door, they're going to put 10 holes for lights in, from 2 on the bottom, 2 on or 1 on the bottom, 1 on the top of each side of the door. So just keep that in mind. If you see an LED light install, I've seen it where they screwed the pooch big on this and they didn't seal any of the doors properly. After they were done, we had to go back in there and pull the contact plates off and reseal everything. So after they pulled it off, I had to take butyl or silicone and reseal the holes that they made in the doors. So that's another big one, because that air starts infiltrating in there. You have that temperature difference, so that air is going to suck right in there. It's going to cause ice to build, and then that frame is never going to make temperature. And then either A, get ice buildup inside the case and frost buildup inside the case, or B, you're going to get sweaty the doors because now you can't keep those door frames above temperature. That being said, guys, doors, they're super simple, but a lot of stuff gets missed. I mean, I see a lot of apprentices write up multiple door heaters and aren't bad. Check power at the actual door frame heater. Don't just check it at a terminal block. Go to the actual frame heater and check it. If you're doing a PM, walking by, non-contact voltage meter works okay. Thermal imager works 1,000 times better because you can spot, I can go through three rows of glass doors in like 10 minutes, look at the thermal imager and see which doors aren't working or which frames aren't heating right away. The frames glow red, the doors glow red. If they're blue, the frame heaters aren't working. So I know that. So just keep that in mind, guys. You can get a cheaper thermal imager for a couple $100. It'll make your life more easy and you'll be more efficient. So it'll pay for itself in the long run. The other thing is just, using a non-contact voltage meter or the amp clamp, just making sure you actually have power and you're checking it out and not just writing up heaters. I see relays get, anti-sweat controllers cause problems. Anti-sweat controllers get a lot of bad rep, but a lot of times they're just not set up properly. So just making sure they're set up, read their manual, making sure it's set up properly is a huge thing. All right, guys, thanks for listening and have a nice day.